any physical condition or any chemical condition, the total mass of the reactant will be equivalent to the total mass of product. All atoms of a given element have identical properties including identical mass. In one element, all atoms will be same or identical and all atomic properties will be same. Each element will be having its own atomic mass. If you have a compound, it will be different elements. That if each element will be having different mass, that mass you should calculate. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College, Temple of Excellence in Mysore. So, today we are in session 3 of the chapter Some Basic Concepts of Chemistry. In the last session, we have discussed about mass and weight, volume, density, temperature, scientific notation, precision versus accuracy and significant figures. About these things we have discussed with the calculation part also and how to calculate the significant figures with its rules. In this session, we will discuss about dimensional analysis, law of chemical combinations, Dalton's atomic theory, mole concept and molar mass. These are the concepts today we are discussing about. Dimensional analysis. First we will understand what is dimensional analysis. There is a need to convert units from one system to another. This method is called factor label method or unit factor method or dimensional analysis. What does it the statement is telling means? 1 unit means if it is in an inch or if it is in a meter, you should convert it into another unit. That conversion of 1 unit to another unit, we'll call it as dimensional analysis. This dimensional analysis can be called in other two names, that is factor label method or unit factor method. Okay. If we tell the statement, you will not able to understand. So, we'll see the example. A piece of metal is 3 inch in long. What is its length in centimeter? See here, they have given a piece of metal with 3 inch. Okay, you have to convert it in a centimeter. So, first you have to know the relationship between 1 inch will be how much equivalent in centimeter. So, for that we should know 1 inch will be equivalent to 2.54 centimeter. Okay, this is the conversion method. 1 inch will be equivalent to 2.54 centimeter. Then what they have to do? 1 inch by 2.54 centimeter means 1. Like this you have to take with denominator. Okay. Later both of these are called unit factors. If some number is multiplied by these unit factors, it will not be affected. See, first we have converted into this centimeter equivalent to 1 inch. Later you have to convert or multiply it by that single unit factor. So, what they have asked for 3 inches. Now we know that for 1 inch, you have to multiply 3 into 1 inch. Later, 3 given above is multiplied by the unit factor. So, that is 3 inch equals 3 inch into 2.54 by 1. For 1 inch, this centimeter. Now, we have to multiply for 3 inch. How much you will get? 3 into 2.54 equals 7.62 centimeter. Like this, you have to convert from one unit to another unit. We'll see another example here. How many seconds are there in 2 days? Okay. In 2 days, how many seconds will be present? You have to find out. We know 1 day will be, in 1 day, 24 hours. 1 day by 24 hours means, if any we can write it in another way, that is 24 hours for 1 day. Then 1 for 1 hour, 60 minutes, right? See, for 1 hour, 60 minutes or 60 minutes in 1 hour. For converting 2 days to seconds, you have to convert completely, that is 2 days to seconds. We know now 1 day means 24 hours, 1 hour means 60 minutes. By taking all the factors, you have to do one step like this. 2 days, for 2 days, 24 hours per day. again 60 minutes per hour, 60 seconds per minute. You have to convert everything till second. Second is the unit for time, right? So 2 days into 24 by 1, 24, 60 by 1, 60, 60 by 1, again 60. All things by multiplying you will get 170 to 800 seconds. Okay, by this you have to convert. Once again see here, day will be converted into hours, hour will be converted into minutes, minutes will be converted into seconds. Okay, second is the unit for time. Next we will see laws of chemical combinations. For the chemical reaction there are so many laws will be given. According to those law only chemical reaction will be understood. So for those law we will call it as law of chemical combinations. What are those laws means? Law of conservation of mass, law of definite proportions, law of multiple proportions, law of gaseous volume or Gay-Lussac's law, and Avogadro's law. These are the 5 laws of combination in which with respect to chemical reactions we are looking up. First we will see the law of conservation mass. This law was proposed by A. Lavoisier. What does the law states means? In all physical and chemical changes, the total mass of the reactant will be equal to total mass of the product. Okay. In any physical condition or any chemical condition, the total mass of the reactant will be equivalent to the total mass of product. In other words, matter can neither be created nor be destroyed. Matter we cannot create nor destroyed. These things have been told by Lavoisier. And with any experiment, we can illustrate the whole conditions. The following experiment illustrate the truth of this law. See here, 2 molecules of hydrogen has been taken with oxygen. What will it form? 2 molecules of water will form. But here mass will be 4 gram of hydrogen, 32 gram of oxygen. How the 4 gram of hydrogen will be given? Mass of hydrogen is 2. Again 2 will be multiplied 2 is 4. Mass of oxygen is 16. Again it will be multiplied by 2. It will give 32. Here also overall 32 plus 4, 36. See here, total mass of reactants is 4 plus 32. 4 plus 32 is 36. The product is, total mass of product is 36 gram. This is what the law of conservation mass has been given. Okay. Next we will see law of definite proportion. This law was proposed by Joseph Proust. Okay. What does it say means? A given compound always contains exactly the same proportion of elements by weight. The given compound always contains a exactly same proportion of the elemental weight. Okay, whatever the elements present in the each compound, it will be equal proportionate for the whole compound. So we'll see example. Water contains hydrogen and oxygen always combined in the ratio by 2:16. Water means hydrogen and oxygen will be always having the proportion of 2:16 or 1:8. This is the definite proportion of the given compound. One water molecule will be equivalent to 2:16 or 1:8. Okay. For example, another example, ammonia contains, ammonia means NH3. Okay. Ammonia contains nitrogen and hydrogen in the ratio 14:3. 14 is the mass of nitrogen, 3 is hydrogen. Okay. 14:3 ratio. Next we will see law of multiple proportions. In the last slide we have seen about what definite proportion in each element of given compound. Here the law was established by a John Dalton. If two elements combine to form 2 or more compounds, the weight of one of the element which combines with a fixed weight of the other in these compounds bear its simple whole number ratio by weight. If two elements combine to form two or more compounds, weight of the one element will be combines with a fixed weight of other. One element having a fixed amount will be combined with another fixed amount element. That time it will form a compound. Two or more compound. It will be whole number by ratio of its weight. For example, see here, hydrogen and oxygen combine to form two compounds, H2O and hydrogen peroxide. These two compounds are different. But for these two compounds, elements are same, hydrogen and oxygen only, but with a different proportion. Here the proportion is different, here the proportion is different. By differentiating the proportionate, you can form two or more compounds by using same elements. That's what they are telling. Masses of oxygen combined with fixed mass of hydrogen 2 gram are in the ratio 16:32 or 1:2. Okay. And sulfur and oxygen combine to form sulfur dioxide and sulfur oxide. The masses of oxygen combining with fixed mass of sulfur, that is 32 gram, are in the ratio 32:48 or 2:3. One side you will be having fixed proportion, another side you will be having the element with the fixed proportion, you will be varying that amount of element, then that time you will be having two or more kinds of compound, but with the whole number ratio by its weight. Okay. Next, Gay-Lussac's law or Gay-Lussac's law of gaseous volume. The law was established by Joseph Louis Gay-Lussac. His name only have given for this law. The law states that under similar conditions of temperature and pressure, whenever gases combine, they do so in volumes which bear simple whole number ratio with each other and also with the gaseous products. Here, similar condition with having temperature and pressure. Also combine with volumes. Okay. What they will combine? The gaseous molecules will combine to have a gaseous product. We'll see one or two example to understand this law. Combination between hydrogen and chlorine. Both are gaseous molecules only. See here, hydrogen and chlorine with one volume and one volume. It will form two volumes of HCl, that is hydrochloric acid. The ratio of volume is 1:2. Okay, here the volume range will be changes. Another example, combination between nitrogen and hydrogen. The two gases lead to the formation of ammonia gas under suitable conditions. Suitable conditions means temperature and pressure will be produced there. Nitrogen is 1 volume, hydrogen is 3 volume. Overall, combining everything, you will get 2 volume of ammonia. What is the ratio? 1:3:2. That's what this law will stating. Next is Avogadro Law. The law was established by a chemist by Amedeo Avogadro. Avogadro proposed that equal volumes of gases at the same temperature and pressure should contain equal number of molecules. What he told here, that same condition, temperature and pressure should be same and equal volume should be present to form a equal number of molecules. See here, 1 ml of hydrogen, oxygen, ammonia. The volume is constant for all the things, or a mixture of gases taken at the same temperature and pressure contain equal number of molecules. Okay. This is the Avogadro law. After all seeing the law of chemical combinations, we are seeing up the Dalton's atomic theory. In 1808, Dalton published a new system of chemical philosophy in which he proposed the following. What he proposed, a Dalton means he is a John Dalton, a chemist. He proposed a new system of chemical philosophy. In that, he gave so many statements or postulates about matter. Matter consists of individual atoms. We know matter will be consisting of individual atoms or containing so many atoms. All atoms of a given element have identical properties including identical mass. In one element, all atoms will be same or identical and all atomic properties will be same. atoms of different elements differ in mass. It's a correct statement, like if element is same, the atoms present in the element is all are same. If the element is different, in that element those atoms will be same, but comparative to other element, those atoms will be different in properties, different in mass also. Compounds are formed when atoms of different elements combine in a fixed ratio. When the compounds will be formed? The compounds will be formed by mixing up of 2 or 3 elements. Different elements will be taken and to form compound, but for the formation of compound, whatever the elements you have taken, it should be in a fixed ratio. Chemical reaction involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. For the processing of chemical reaction, here molecules or atoms will be reorganized, nor created or not destroyed. You cannot create any kind of molecules. Whatever molecules are present, it will be reorganization will be taken place. That's all. It will be not create. Any molecule is not creating any new molecule or not destroying any molecule. It will be just reorganized. Okay. And whatever mass you are used in a reactant, you will see in the product after combination. Okay. Mass is also not less or not more. It will be equivalent to the mass of reactants. Next is atomic mass. It is the ratio of mass of one atom of element to the 1/12 mass of one atom of carbon 12 isotope is called atomic mass. It's nothing but any atomic mass of element will be equivalent of mass of one atom of an element 1/12 of the carbon 12 isotope. If you see in this way, you will able to understand. See here, mass of one atom of carbon 12 atom is one side. You have to multiply with mass of one atom of an element. Whatever element you have to see, that element mass you have to see and into 1/12 of carbon 12 isotope. If you multiply both the things, you will get atomic mass of an element. Carbon 12 as the standard, carbon 12 is the standard here and has been agreed up in 1961. Here carbon 12 is one of the isotopes of carbon and can be represented as 12C. In this system, 12C is assigned a mass of exactly 12 atomic mass unit, that is AMU, and masses of all other atoms are given relative to the standard. For why they have given carbon 12 only, they have showed that it is exactly assigned of 12 atomic mass unit. That's why they have taken. What is that? Carbon 12, that is the isotope of carbon. It should be, the carbon 12 only should be standard. It was agreed in the year 1961. Okay. By this using standard only, they are finding out all the atomic masses. They have already found out the all atomic masses of an element. Next we will see atomic mass unit. A mass exactly equal to 1/12 of the mass of one carbon 12 atom. Whatever we have seen in the last slide, that only, okay, 1 AMU means mass exactly equal to 1/12 of the carbon 12 isotope. The one part will be the 1 AMU. Then 1 AMU equals 1.66056 into 10 to the power of minus 24 gram. The 1 unit by 1/12 is equivalent to these things. Atomic mass expressed in AMU, but nowadays atomic mass will be called as unified mass. You can call it as AMU also or unified mass also. What is the average atomic mass? The average relative mass of an atom of an element as compared to the mass of carbon atom taken as 12U. If you take 12 AMU one side, the remaining side will be the average atomic mass of the particular element. Then what is gram atomic mass? Relative atomic mass of the element is expressed in grams. If the atomic mass expressed in grams, that will call it as gram atomic mass. You should remember the value of 1 AMU. Okay. Then molecular mass. It is a ratio of the sum of average atomic masses of the different elements in a molecule to the mass of 1/12 of one atom of carbon-12 isotope is called molecular mass. See, whatever the compound, what is compound? Compound means different elements will be taken with a fixed ratio to form a compound. Each element will be having its own atomic mass. If you have a compound, it will be different elements. That if each element will be having different mass, that mass you should calculate. Overall, by calculating, you will get the molecular mass. First, you see the example here. Calculate the molecular mass of glucose. How you will write the glucose in molecular formula? That is C6H12O6. This is the molecular formula for glucose. But now, how you will calculate the molecular mass? See here, 6 molecule is present. You have to write 6. What is the atomic mass of carbon? That is 12. 6 into 12. Again, 12 molecule of hydrogen. What is the atomic mass of hydrogen? 1. Again, 6 in what is the atomic mass of oxygen? That is 16. 6 molecule of oxygen is present, that's why 6. By taking off all the sum of the elemental atomic masses, you will get 180.162 unified mass. That is how the molecular mass will be calculated. This is a compound with different elements, correct? Its atomic mass have been taken with the number of molecules. After all taking, you have to take a sum. Sum means overall average, not average, you have to get overall additional product that you have written here. That's all. What is gram molecular mass? Molecular mass of an element, if it is expressed in grams, we'll call it as gram molecular mass. Next is formula mass. The formula mass of a molecule is the sum of the atomic weights of atom in its empirical formula. We'll see example. What is the formula mass of potassium nitrate? First you have to write it in a molecular formula. For potassium nitrate, KNO3 is the molecular formula for potassium nitrate. Same thing you have to write, like one molecule is present, mass of potassium is 39.09. Again nitrogen is one molecule, mass of nitrogen is 14. Here oxygen 3 molecule is present, that's why we have written 3. This one, mass of oxygen is 15.9, around 16. After getting all the multiplication and addition after doing, you will get 10.102 unified mass you will get. This is how the formula mass will be identified or calculated. Next we will see the mole concept and molar mass. First we have to understand what is 1 mole. 1 mole is the amount of substance that contains as many particles as there are atoms is exactly 12 gram. What they are telling? 12 gram of the 12 carbon isotope wherever is present, means how much is present, it will be equivalent to 1 mole. The atoms or particles present in the 12 carbon isotope will be equivalent to 1 mole. Okay, the number of entities in 1 mole is substance is known as 6.022 into 10 to the power of 23. This is the 1 mole value or the exactly 12 grams present in the 12 carbon isotope. It will be equivalent. Example, 1 mole of hydrogen atoms is 6.022 into 10 to the power of 23 atoms of hydrogen. The mass of 1 mole of substance is in grams is called as molar mass. Okay. The molar mass of water, see here 18.02 gram per mole. The number of moles of atom, mass of substance in grams by gram atomic mass. You know now what is gram atomic mass? Then mass of substance in grams. By this, the mole concept and the molar mass will be identified. See here N equals W by M. This is the short form of this formula. Okay. Whole mole concept and molar mass will be still continued. Those things you will see in the next session. In the next session, percentage composition, empirical formula, molecular formula, stoichiometry and stoichiometric calculations, limiting reagents, expressing concentration of solutions. These are the parts of many calculations you will see in this content, and many interesting formulas and many interesting concentrations of solutions you will be seen. I hope you have understood what I have taught today. So we'll meet in the next session. Thank you.